Hey pre-calc students, just wanted to make a quick video about evaluating sine, cosine, and tangent on the unit circle. It's important to remember that these sine, cosine, and tangent are all about trig ratios of an angle. So if you have the sine of some angle, you'll get a ratio or some type of fraction or proportion based off of this angle measurement. So an angle is always going to go inside of the trig, and then out will come the value of sine or whatever trig you're doing. So if you're doing cosine, the angle will go inside the cosine, and what comes out is the value. This is also function language. So you have an input of an angle measurement and an output of the function's value, sine or cosine or tangent. So you've been learning about what the unit circle is and how to memorize the unit circle. But just a reminder, the unit circle is just an organizational tool of exact sine values. On the inside of the unit circle, you have angle measurements in both forms. So the degree angle measurements of all angles from 0 to 360, and all radian measurements from 0 all the way to 2 pi. On the outside of the circle are the coordinate points. And the coordinate points represent two very important things. The x of the coordinate point is the cosine value at the specific angle, and the y of the coordinate point is the sine value at that specific angle. So cosine is always your x and sine is always your y. So how we can use this? Let's say I wanted to find cosine of 90 degrees. So the first thing I'm going to do is I'm going to start at 0 degrees, and I'm going to rotate to 90 degrees. 90 degrees is up here. It would make a right angle. You can draw a little box there. And I'm going to go towards that 90 degrees. Once I'm at 90 degrees, I'm going to go to the coordinate point. The coordinate point at 90 degrees is 0, 1. 0 is our x value. 1 is our y value, and because they're asking for cosine, they are wanting the x coordinate point at 90 degrees. So the answer to cosine of 90 degrees is 0. You can type this into your calculator in degree mode, and it would tell you that cosine of 90 degrees is 0. Again, this unit circle is just an organizational tool that helps you evaluate these trigs without the use of a calculator. Okay, so if I wanted to do sine of 210, the first thing I'm going to do is I'm going to start at 0 degrees, and I'm going to rotate. So starting at 0 degrees, I'm going to rotate around my circle, rotating around my circle until I get to 210 degrees. So here's 210 degrees. I have my coordinate point, and because I'm asking for the sine value, I want the y of that coordinate point. So I'm going to use the second value at my coordinate point, which is -1/2. So sine of 210 degrees is -1/2. Okay, next problem. Cosine of 45 degrees, or excuse me, -45 degrees. If you remember from a video that you should have watched earlier this week, a negative angle measurement is formed by rotating clockwise rather than counterclockwise. So positive 45 degrees is up here. That's this angle measurement. Negative 45 degrees is going the same distance, but in the negative direction. So the same amount of distance. So when I say this -45 degrees, this is the same thing as finding cosine of 315 degrees. These are going to have the same exact value. The cosine value is our x coordinate. So I'm going to use that first value. And so the answer to both of these, cosine of -45 degrees, which is the same answer as cosine of 315 degrees, is the square root of 2/2. Okay, for my next problem, I'm going to find negative cosine of 4 pi over 3. So I'm going to start at 0 degrees. I'm going to rotate around my circle 4 pi over 3 radians. So there's pi over 2 radians, pi radians, 4/3 pi radians. So I have an angle measurement that is over 180 degrees, over pi radians. So I want to be looking at 4 pi over 3. Then I notice that I want the cosine value at that coordinate. So I have negative 1/2. Okay, so the first thing I want to talk about is that I'm looking for the cosine value at that negative 4 pi over 3, and that is negative 1/2. But I also notice this negative out front, so I'm going to make this value negative, and we remember that two negatives make a positive, so the negative cosine of 4 pi over 3 is positive 1/2. See if you can try the next two problems on your own. Pause the video and see if you can try those. Okay, so for this next problem, I found the sine of pi over 2, starting at 0, going to pi over 2 radians, and I found the sine value, which is 1. So the sine value at pi over 2 is 1, but then this was being multiplied by negative 4. Negative 4 times 1 is negative 4. The last problem, we had sine of negative pi over 2. A positive pi over 2 measurement is a quarter of a circle. So a negative pi over 2 measurement is a quarter of a circle down. So I'm looking for the sine value at 3 pi over 2. So this is the same thing as finding the sine value of 3 pi over 2. Sine value again is the y coordinate. So I found the y coordinate, which is 1. Last trig function that we'll talk about on the unit circle is the tangent trig function for this video. So tangent on the unit circle does not immediately show up, right? We know that cosine is the x value, sine is the y value. And so what we're going to end up doing is using a combination of the x and the y value in order to find tangent. So tangent of a angle can be defined by the sine value at that angle over the cosine value at the angle. Essentially on the unit circle, what this means is we are taking the y value and dividing it by the x value. So anytime you want to find tangent, you're going to be using the division of the two values in that coordinate point. For example, if I wanted to find tangent of 45 degrees, my first goal is to find 45 degrees. 45 degrees is here in quadrant 1 on my unit circle. And tangent of 45 degrees is the same thing as finding sine of 45 degrees and dividing that by cosine of 45 degrees. The sine value at 45 degrees comes from the y value at that coordinate point. Sine's value at 45 degrees is the square root of 2 divided by 2. And the cosine value at 45 degrees comes from the x coordinate, which is the same square root 2 over 2. So I can simplify this. I see something being divided by itself, so this will simplify down to 1. So tangent of 45 degrees has a value of 1. Again, you can check this by typing tangent of 45 degrees in your calculator in degree mode. This is using the unit circle to find these values rather than having to use a calculator. This is going to be really important when you get to calculus. Part of your calculus experience, whether that's in college or whether that is in high school next year, is calculator inactive. So knowing these values on this unit circle is going to be really important for you to understand these trig functions. Okay, I'm going to do one more example of the tangent on screen, and then I'll let you guys try some practice on your own. So the first one that we'll do is tangent of 150 degrees. So on my unit circle, I'm going to find 150 degrees, and we know that tangent can be found by doing the sine over the cosine, which is the same thing as taking the y value over the x value. So in my 150 degrees, my y value is 1/2, and my x value is negative square root 3 over 2. So if I could leave a fraction in this form, this would be my answer, but anytime we have a fraction divided by a fraction, we want to simplify that by multiplying by the reciprocal. So I'm going to leave my first fraction as 1/2, and I'm going to multiply by the reciprocal of my second fraction, so 2 over this square root of negative 3. Multiply fractions straight across, and I'm going to look for ways that I can simplify. 2 times 1 is 2. 2 times the negative square root of 3 is negative 2 square roots of 3. My 2's can simplify, which would give me 1 over negative square root of 3. And if you remember, you can't leave a radical in the denominator. A radical in the denominator. We want to rationalize it. So we're going to multiply our square root of 3, top and bottom, so that we can have a rational denominator. So 1 times the square root of 3 is the square root of 3, over the square root of 3 times the negative square root of 3 will be negative 3. So that is my final answer of tangent of 150. Pause the video and see if you can try these 3 problems on your own. Okay, make sure when you have 0 in the denominator, we're using the word undefined. So tangent at negative pi over 2 is an undefined value, whereas 0 divided by negative 1 is just 0. So tangent at pi has a value of 0. For tangent at 240 degrees, I did the y value divided by the x value, multiplied by the reciprocal. 2 negatives became a positive when multiplied. I reduced my 2 over 2, and I got square root of 3. The square root of 3 is not in the denominator, so it does not need to be rationalized. So this can be my final answer. Hey pre-calc students, just wanted to make a quick video on the order of operations with trig. Many of you are familiar with PEMDAS, which stands for parentheses, exponents, multiplication, division, addition, and subtraction. And this is the order in which we complete operations when we see them. With trig is an operation that comes right after parentheses. So anything inside of the trig parentheses you'll do, then you'll evaluate the trig, and then you'll follow the remaining order of operations. So trig kind of sits right after the parentheses, where you simplify the trig value once you have your parentheses simplified. Okay, so we're just going to do some examples in the next couple slides. So we're going to evaluate this trig function. So we have sine of 2x, and we know that x is 90 degrees. So the first thing I'm going to do is we know that x is the value of 90 degrees, so I'm going to use substitution to replace that. So this is going to be the same thing as sine times 2, or sine of 2 times my 90 degree angle. I'm going to use PEMDAS, so I'm going to do parentheses first. Inside my parentheses, I have 2 times 90 degrees, which is 180 degrees. And then after parentheses, the only thing remaining is sine of 180 degrees. Pulling this from our unit circle, we want the y value at 180 degrees, which is 0. You're going to want to have your unit circle out for this video so that you can also find these values as well. Our next example is negative cosine of x plus 45 when x is 180 degrees. Pause this video and see if you can try this problem on your own. Okay, so the first thing that I did was I substituted my value of x of 180. I did my addition inside my parentheses first, and I got 225. I evaluated my trig. Cosine at 225 degrees is negative square root 2 over 2. And then my final step was to do negative and negative to make it a positive square root 2 over 2. Our next example is 3 times sine of x divided by 2 plus 5. And we're going to let x equal pi. Again, I think you can try this problem on your own. See how much of this you can do without me. Okay, the first thing I did was I substituted in pi for my x value. Pi over 2 cannot be simplified, so I'm going to find my trig value at sine of pi over 2. Sine of pi over 2 on the unit circle is the y value, which is 1. Then I'm going to do my multiplication, so 3 times 1 is 3, and then last addition of 5. So my total value of this expression when x is pi is 8. Next example that we'll do is negative 3 times the cosine of 2x plus 2, and I'm going to let x equals pi over 4. Again, first step is substitution. For my 2 times pi over 4, this can be simplified. So I'm going to do 2 over 1 times pi over 4 and multiply straight across. So that's going to give me 2 pi over 4, which can be reduced to 1 pi over 2 or half of a pi. So this can be reduced to pi over 2. And this is still inside my cosine, -3 plus 2. Cosine of pi over 2 is the x coordinate. That's going to be 0 times -3 plus 2 is 2. Take a second and see if you can try this problem on your own. 1/2 cosine of 2x minus 4 when x is 3 pi over 4. Make sure to check your work when you're doing 2 times the 3 pi over 4. Multiplying our fractions, we'd get 4 or 6 pi over 4, which can be reduced to 2 pi or 3 pi over 2. Cosine of 3 pi over 2 is the x coordinate, so 0, and then times 1/2 minus 4 is -4. Our last example for this video is going to incorporate a exponent. So here I have the sine of x, and that's being squared, and x is 5 pi over 4. So first thing I want to mention is some textbooks will also write this as sine squared of x, but either way you're following your order of operations. So the first thing is simplify anything you can inside the parentheses. So sine of 5 pi over 4. 5 pi over 4 is a value on our unit circle. It can't be simplified, so I'm going to go ahead and pull this sine value. So we'll do the trig after we do the inside the parentheses. So sine at 5 pi over 4 is going to be -√2 over 2. And then after I do the trig, I will do my exponent. I'm going to square that. Remember, squaring something is the same thing as multiplying by itself. So this is -√2 over 2 times -√2 over 2. And two negatives will make it a positive. Square root 2 over 2 times square root 2 over 2 is 2. 2 times 2 on the denominator will be 4, so this can simplify to 1/2. The only time you would ever do an exponent before you would evaluate the trig is, let's say the exponent was inside the parentheses. So if this was sine of x squared and the x value itself was being squared, that's when the exponent would become before the trig, is when that exponent is pulled inside of that parentheses. But other than that, you'll do the trig first and then the exponent second. And that's it for order of operations.